Lesson 80, calculating frequency distribution. First off, some vocabulary words. Discrete events just means events with finite number of outcomes, a certain amount of outcomes. Compound event means event consisting of two or more simple events. And then the main focus today, frequency distribution, shows the number of observations falling into several ranges of data values. Let's take a look at some examples today. A baseball player bats multiple times in a season. The table shows the results of each at-bat. Make a bar graph that shows the frequency distribution of the data, and then find the experimental probability of each outcome. So for this one, the graph has already been done for us. They used the bar graph to show all the different outcomes of their at-bats. Now we need to find the probability of each outcome here. And to do that, we find out how many total at-bats there were. So I just add up all the outcomes that you have here. We have 30 plus 36 plus 20 plus 9 plus 3 plus 1 gives us a total of 99. So I would put all of these numbers over 99. And then from that point, I just simplify. So for this one, 30, I can divide each one by 3, and that would give me 10 over 33. I can divide 3 out of 36 and 99. 36 divided by 3 would give you 12 over 33. This would stay at 20 over 99. And divide a 9 top, so it's 1 out of 11. Divide a 3, that gives us 1 out of 33. And then this is 1 out of 99. So there I gave the probability of each outcome. We have our bar graph to the right, so you can see how it would shape up. Next, a man bowls 5 games. He keeps track of how many pins he knocks down on the first try of each term. Make a bar graph that shows the frequency distribution of the data, and then find the experimental probability of each outcome. So here the number of pins and the frequency, it's happened once. So the number of pins is your x-axis. So a 0. How many times did you hit 0 pins? That happened once. So a halfway point. So here, what number of pins? Once was 0, so I don't shade anything. 2 was 0. 3 pins happened 4 times. That'd be 2 boxes. 4 pins happened once. 5 pins happened twice. 6 pins didn't happen at all. 7 pins happened 6 times. 8 pins happened 17. 9 pins happened 8 times. And 10 pins happened 11 times. Now that we have our graph done, now we can find the probability of each outcome. So the frequencies, we can see how many that was. So 1 plus 4 plus 1 plus 2 plus 6 plus 17 plus 8 plus 11 gives us 50. So number of pins, 0 pins would be 1 out of 50. 1 pin is 0. 2 pins, 0. 3 pins, 4 out of 50, which is 2 out of 25. This would be 1 out of 50 for 4 pins. 1 out of 25 for 5 pins, 0 for 6. 3 out of 25 for 7 pins, 17 out of 25 for 8, be 4 out of 25 for 9, and 11 out of 50. Going back to the 8th, that would be 17 out of 50. So 11 out of 50 would be 10 pins. So from there, you can see which one you have a better chance of getting. Looks like the best chance you have of getting it would be 8 pins, which is 17 out of 50 chances. Next one, represent data with a table. A student spins the spinner and flips a fair coin. Make the table to show the possible outcomes in this experiment, and then find the theoretical probability of each possible outcome. So you can get heads reds, heads blue, head red, head yellow, or you can get tails red, tails blue, tails red, tails yellow. So the probability of getting heads red, it was 2, we have 2, 4, 6, 8, 2 out of 8, which is 1 out of 4 chances. To get heads blue, there is 1 head blue out of 8, so 1 out of 8. We have heads yellow, which happens 1 out of 8. And then tails blue, or tails red is 1 out of 4 because we have 2 of those. And then tails blue would be 1 out of 4, or 1 out of 8. And tails yellow would also be 1 out of 8. Next, student flips 2 coins, make a table to show all the possible outcomes in this. So here you're doing the same thing, you get heads, heads, or heads, tails, or you got tails first, then heads, or you got tails, then tails. There are 4 possibilities, so heads, 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 tails, and tails, tails. So in order to get 2 heads, you have 1 out of 4 chances of that happening. To get a heads and a tails, there are 2 of those. So heads, tails, slash tails, heads, those are the same. That would give us half a chance because you have 2 out of 4. 2 out of 4 we would say is half. Then tails, tails, that's 1 out of 4 chances. Next one, suppose that the 11 cards each contain 1 letter from the word Mississippi. Make a bar graph to represent the frequency distribution for all the possible outcomes. Find the theoretical probability of each outcome. So there's 1 M. There are 1, 2, 3, 4 I's. There are 1, 2, 3, 4 S's. And there are 2 P's. There's our graph, the theoretical probability. So getting an M, we have 1 out of the 11. We have 1 out of 11 that's an M. The I's, we have 4 out of the 11, they're I's. S's, we got 4 out of 11. And the P's, we have 2 out of 11. So if you were to put those in a hat, those cards in a hat, you have a better chance of picking an I or an S than you would with an M or a P. And our final one, a toddler tears off the labels on several soup cans. There were 6 cans of vegetable soup, 3 cans of tomato soup, 2 cans of potato soup, and 1 can of clam chowder. 1 can is randomly chosen to open. Make a bar graph to show the frequency distribution for all possible outcomes. Then find the theoretical probability of each outcome. So vegetable soup, there were 6. Tomato, there's 3. Potato, there's 2. and clam chowder, there's 1. So the probability, since there are 6 plus 3 is 9, plus 2 is 11, plus 1 is 12. You got 6 out of 12, which is 1 out of 2 for vegetable. 3 out of 12, which is 1 out of 4 for tomato. 2 out of 12, which is 1 out of 6 for potato soup. And we got 1 out of 12 for clam chowder. That's our lesson today on calculating frequency distribution.